This is the variable frequency oscillator based on a PLL chip, the phase loop chip SI5351, and all driven by a microprocessor, one of the ESP32 range. All fits in a fairly compact box, battery controlled and USB controlled. So controls are very simple. There's a rotary, there's a switch for the battery, an LED, and there's a USB-C connection, and on the back we've got an SMA and a couple of flying leads for test purposes. So the whole thing is very compact, quite neat. So to show us powering up here, here is I'm not sure how this is going to come out, but here's the welcome screen. It's a fairly small display. I think it's 1¼ inch, 320 by 240 pixels, and that's integral to the ESP32 development board. So the board itself is very neat. It's one of the TTGo boards, TTGo T-display. Very attractively priced, very powerful. Controls are quite simple, purposely so. So the rotary switch here, it's a rotary encoder. It allows the frequency, which is currently set at 100 kilohertz, allows the frequency to be changed in preset increments. So at the moment we have the main VFO frequency here. We have the particular band that we're on, which is the long wave, medium wave band here, and we have step increments set at 10 Hz. There's a separate output here for BFO, which I may or may not use at some downstream. This is set at a typical AMIF frequency of 455 kilohertz. So there are actually 3 oscillator outputs available from this board, and I'm just using 2 of them. So to show again the typical operation of the rotary encoder, set at 100 kilohertz, step size set at 10 Hz. So when the rotary is moved, the frequency increments in 10 Hz steps. Okay. Now there's also a push button set into the encoder. So depressing the push button changes the step size. So you can see the step size has been increased there to 1 kilohertz. Now turning the rotary encoder allows us to change through the frequencies in much quicker steps. I've got this set to go right up to 1 megahertz. Okay. Now the other item of interest is the band, because at the moment this just goes from 100 kilohertz up to 1800. But if I long press on the encoder switch, I then have access to a menu of other options, and if I put it into band change, you'll see that there's a number of bands available I can preset. So very small text, because there's quite a lot to get in here. What I've got is the band name on the left hand column, the minimum frequency in the middle column, and the maximum frequency on the right hand column. And I'm currently on the band that's highlighted in yellow. So now moving back to the rotary encoder, if we turn the rotary encoder by 1 click, we change it onto a different band. What I've got is all the amateur bands with other bands interleaved in between them, just to give me a continuous coverage. So that's highlighted on 80 meters. So if I now short press the switch, that's me on to 3500 kilohertz, or 3.5 megs for the 80 meter band. looking at some of the other bands. Hopefully you can see this, it's quite small text. So there's 60 meters, 40 meters, 30 meters, 20 meters, 17, 15. So if I run it right down to the 2 meter band, what I hope to show you is evidence that the oscillator is actually working. This has been checked using an oscilloscope up to about 100 megs, but I don't have anything, any test equipment to work beyond that. But what I can do is, by choosing the 2 meter band and by using my trusty 2 meter handset here, show you that we're actually transmitting. So at the moment I've got the 19 band on FM simplex, which is 145475. So if I now set the oscillator to the same frequency, let's see what we do. You can hear evidence of life. 145, 475. Okay. So if you have a look at the receiver for a minute, the handset, as I move one step on the encoder, you can see that the green light on the top comes on, and you can see the little blue receiver light lighting up, and you can see the antenna signal on the top left going from nothing to signal. I've also been able to check this with my HF set, but going beyond that, I've got nothing that will actually check operation. In theory, this will go up to certainly 180 megahertz, but it may also go beyond that depending on the particular manufacturer of this particular chip. So that's all I wanted to show, just that the oscillator is capable of operation from the range of 10 kilohertz up to at least the 2 meter band. The other thing, just to demonstrate quickly, is that there is actually an inbuilt battery, so I can. It's a rechargeable Li-Poly, and operation is identical. This particular development board that I'm using has got very low consumption, but it's also got an integrated Li-Poly charger with a JST connector, so it's possible to buy, I've got a 1000 milliamp hour Li-Poly battery in here, and it's charged every time the USB connection is made. And operation is certainly very, very efficient. Okay, well that's it for this video. Thank you very much for your interest. The box is one that I 3D printed myself, and the design for that is also made available online. This is MM0MMQ signing off.